All right, guys, starting over again with this study guide here. This is the Chapter 1 review. It'll get you ready for Chapter 1's test. And I'm going to break this video up into two sections. The front side will be one video, and the back side will be another. All right, what I want to talk to you about is that I already filled in 1, 2, and 3 because I was having some volume issues on the last one. Yay for technology. Anyway, so you'll notice that for number 1, I put it as true, that A, D, and F are coplanar. Well, A is here, D is here, and F is right there. If you were to shade this side of the pyramid, the side that they're talking about, you would see that F is in fact coplanar. It lies on that side of the pyramid. And we move over to number 2. Well, here's line AC, if you can see that, and FE. Well, those don't lie on the same plane, so false. They are not coplanar. We move down to number 3, and we look at ABE. Are they coplanar? A, B, and E. Well, yes, they would be this side of the pyramid over here, and true, they are coplanar. Moving along over here, D, A, B, and E. Coplanar. Let's check and see. D, A, B, and E. Yes, they all lie on this side of the pyramid, and true, it would be coplanar. And we look down here, A and C. Well, here's a straight line right here, and A and C, yes, true, they would be collinear. And then D, E, and B. They make an angle, but they do not make a straight line, so false. They are not collinear. All right, as we move along down to numbers 7 through 12, I really want you guys to focus or pay attention to the fact that all the way down to 12, we are going to use this diagram right here. So paying attention to that, let's look. It says that BC, right here is BC, it's 12. And CE, the entire line over here, is 15. It wants to know what the distance from B to E is. So I would do 12 plus 15, and I would get the entire distance, which is 27. Okay, that is number 7. As we move along to number 8, look over here, and it says blank is the angle bisector. Well, of what angle? So an angle bisector cuts an angle into 2 perfect halves. Remember, hi-ya, our ninja move. So if you notice here, this angle and this angle are both congruent by those congruency markers. So that means that GC, this segment right here, cuts this angle ACB in half. Angle ACB. That's how we get this congruent angle and this congruent angle. All right, now we're going to move down to number 9. Use the segment addition postulate. So we're going to say that DE, which is right here, is equal to 3x plus 2. Okay, and that CD right here is equal to 5x, whoops, we'll say DE, and 5x minus 10 is equal to CE, whoops, CD, and that CE, the entire segment, is equal to 32. CE is equal to 32. So I think, like I say quite frequently, draw a diagram. Even though there's something up here, it might help you to draw your own little diagram. And it's going to be B and C. Oh, sorry, I messed that up. Oh, I'm all sorts of a mess right now. Sorry, guys. Microphone's falling over. My high-class microphone here. But it's really, really a glamorous microphone. Okay, so let's relabel our points so we can get this correct. We have C here, and D here, and E there. I'm going to go ahead and write in the appropriate expressions. So DE was 3x plus 2. and CD was 5x minus 10. The whole segment equaled 32. I'm going to add those two together. So I will take 5x minus 10 and add 3x plus 2 and set it equal to 32. Remember, guys, I need to combine like terms. So anything with an x, I'm going to combine. And then anything that's just by itself, a constant, I'm going to combine. Well, 3 plus 5 is 8, so I have 8x. And then negative 10 and 2 is going to give me a negative 8, and it will equal 32. All right, so now I'm going to go ahead and solve. I'm going to add 8 to both sides, and I'm going to end up with 8x equals 40. I'll divide by 8 now and divide by 8, and x equals 5. Well, it says solve for x, so we have part of our answer done. X equals 5. Now it says find all segments. Well, the two segments I need to find are DE and CD. They already gave me CE, so I only really need CD and DE. I'm going to start with DE. It doesn't matter which one you guys do. And I'm going to plug our x in. So 3x, or 3 times 5, that's our x, plus 2. And we all know that 3 times 5 is 15. And then plus 2, we end up with 17. So DE equals 17. All right, there's part of our answer. And then we're going to do CD. All right, well, it's going to be 5 times our x, which is 5, and then minus 10. Well, 5 times 5 is 25, minus 10, CD equals 15. We have our x, we have our DE, and we have our CD. The problem with this paper, oh, whoops, sorry, you couldn't really see that well. The problem with this paper is it's just a little hard to fit all of our work in. So we might just run out of room, and I apologize for that. C is the midpoint of AF. Moving on to number 10. All right, so I'm going to draw a diagram. Real shocker there, I know. Here's A and F, and C is going to be the midpoint. Because C is the midpoint, I know that AC and CF are congruent. Because remember, the midpoint tells me they're exactly equal. So AC is equal to 5x minus 16. And CF is equal to 2x minus 4. They want me to find AF. Well, right here, midpoint was what was going to help me solve this. And I'll zoom in a little because it's kind of blurry, but it cuts off our page, so we'll figure it out one of these days. Because it's the midpoint, I get to set these two equal. So I'm going to say 5x minus 16 is equal to 2x minus 4. Okay, I get to set them equal because it's the midpoint. Right here at C, and that means this segment and this segment are congruent. I'm going to subtract 2x because that's what you do to solve, to get your x's on one side and your constants on another. And then I'm going to add 16 and add 16. All right, well, when I subtract 2x, I end up with 3x equals, oops, that was a 16, a 12. Negative 4 and 16 is 12. I'm going to divide by 3 and divide by 3, and x equals 4. All right, that's awesome. I did solve for x, but I need to solve for AF, which is what it was asking for. All right, I can take either of these. I'm going to choose 2 times x minus 4 and plug it into. So AF is going to equal 2 times 4 minus 4. So 2 times 4 is 8. Minus 4 equals 4. And then I'm going to double it because remember that's only part of it. So then I'm going to multiply that by 2. I'm going to get AF equals 8. So there's X and there's my AF. All right, moving along to question 11. It says that BCG is equal to 60. All right, if we look back up here, BCG on this diagram is equal to 60. All right, it wants to know what GCA is. Well, if this is 60, then this has to be 60 because they're both marked congruent. So I move back down and I can say that GCA is equal to 60 degrees as well. And then it wants me to find the measure of BCA. So I'm looking over here, BCA. Well, I now know that this is 60 and this is 60, so the entire angle BCA has to be 120. Okay, as we move down to number 12, we're referring back to the angles again. So I'm going to look over here and hopefully have enough space to do this. And it says that ACD, this angle right here, is equal to 60. All right, and then it says that DCH, this angle right here, is equal to 20. And it wants me to find HCA. HCA, that is this angle right here. So in order to do so, I'm going to do 60 minus 20, which would give me 40. And therefore, the measure of angle HCA equals 40 degrees. All right, and we're going to move down to number 13. Okay, over here in the figure, it says that the measure of P, Q, and R, which is the entire angle, equals 4x plus 47. It wants me to find PQS. Okay, well, we're going to use the angle addition postulate, meaning we're going to take this angle and add this angle and set it equal to the whole angle. Remember, part of the angle plus the other part of the angle equals the whole angle. So here we go. 7x minus 4 plus 36 equals 4x plus 47. All right, here was one of my angles, adding it to the other angle and setting it equal to the full angle. Okay, well, 7x. And then a negative 4 and a positive 36 is a positive 32, which equals 4x plus 47. I'm going to move my x's over. I'm going to subtract 4x and subtract 4x. And I'm going to minus 32 and minus 32. And I will get 3x equals 15. Now I divide by 3 and divide by 3, and x equals 5. There's one of my answers, but now I need to find PQS. So I'm going to take that 5 and I'm going to plug it in. So I'm going to go over here where I have a little bit more room and find PQS. PQS, it is 7x minus 4. So I'm going to do 7 times 5, what my x was, and then subtract the 4. Well, that's going to be 35 minus 4, which equals 31. So the measure of angle PQS equals 31 degrees. Okay. Now we're on to 15. This is where things get a little confusing. So we're going to look here and we're going to think supplementary. Remember, that adds to 180 degrees. Supplementary to NQK. NQK. All right. Excuse me. Okay, so here is NQK. I want it to form a straight line because I know a straight line equals 180 degrees. So I know that this is part of my angle right here, and then this is a straight line. So I'm going to say the angle JQN which would be this angle right here, is supplementary because it forms a straight line. So angle JQN would be supplementary. I could also say, if I move my hand this way, that this angle, angle KQP, is supplementary because it will also form a straight line with angle NQK. So, and angle KQP. Those would be your two possible answers. And then we're talking about vertical angles to PQM. So here's PQM. Remember, kissing angles straight across from each other. I would say angle LQN is vertical, meaning these two angles right here would be congruent. Okay, and now we're going to look at NQJ. NQJ, which is this angle right here. NQJ. Well, it's directly across from PQK, and that would mean that those two angles were congruent. Angle PQK. All right, now we're going to talk about being adjacent and congruent to angle JQM. Well, let's look at this diagram for a sec, and let's look at LQK. It's 90 degrees. Okay, well, it's vertical to this angle right here, JQM, which makes this 90 degrees. Well, JQM is what we're trying to figure out. So I look here, and I see that this is a straight line, right? JQK, which means congruent and adjacent to would be this angle right here, MQK, because together they make up a straight line. And if this is 90, then this angle right here would also have to be 90. So angle MQK. And if this whole angle right here is 90, and we are talking about angle KQP, what would be complementary, meaning it has to add up to 90 degrees. So here's KQP. Well, the only angle complementary to that would be angle PQM. Angle PQM. And that is the first side. Like I said, it's kind of long, so stay tuned for side number 2.